Thank you very much. My topic this morning is called Abstraction Distractions. And let me explain what I mean by that. As developers, we live in abstractions all the time. It's the only way we ever get useful work done. So when you're dealing with a file, you think of it as files and folders. You don't think of it as zeros and ones living on a spinning platter with rust on it. Because you can never get anything done if you always had to think of it as ones and zeros and magnets and all that sort of stuff. So we build these abstractions, and this is good because it lets us work at the file system level and think about files and folders and hierarchy when all of it's really just a myth. It's all just abstractions that we've created. And when we run into trouble is when we start believing those abstractions are the real thing. And that's what I'm calling an abstraction distraction. And these exist in the technology world and the real world, and I'll give you some examples of each. But I'm going to start with a real world example. And I'm guessing that many of you, like me, are the IT support staff for your household. So my wife has gigabytes worth of digital photos, and it doesn't matter if a meteorite comes from space and hits our house. If we lose those digital photos, it's my fault. Because I'm the IT support guy for my family, and I have to make sure that all those files are protected somehow. So what if you have some really, really important family files like this one? This is a chocolate cake recipe that my wife managed to get from one of her relatives at very great effort, and she wants to keep this forever. And it got me to thinking, how would you keep a document as precious as this if you needed to keep it for 100 years? Would you put it in a Word document? I don't know, 100 years in Word? Maybe, but that's a pretty chancy thing to take with something really important like Mary Long's chocolate cake recipe. You might be better off still going just plain text, because I'll bet in 100 years you could still read plain text. You might even go fancy and go something like Unicode. But I don't know, ASCII's probably safer. And you might get really fancy and do something like HTML. So you get a little bit of bold and the bulleted list for the items. I'm pretty sure we'll be able to read HTML in 100 years. But even if not, you can kind of see through the markup. This is kind of a casual concern for me, but there are people whose job this is. There's a company or a part of the U.S. government called the National Archives, and they're responsible for keeping track of all this stuff. And they have to think about how do you store documents for 100 years and 1,000 years. And they have real problems with data formats and things like that. Because how do you know that these formats that you capture are even going to be readable in 100 years, much less 1,000 years? Another group of people who are thinking deeply about this problem is this group of people called the Long Now Institute. And they're working on this project called the Clock of the Long Now. Their challenge is, how can you build a clock that will last and keep time for 10,000 years? So how would you do that? Well, you can't rely on electricity for 10,000 years, so they're using water power. So they had to find a river that was geographically or geologically sound so that you wouldn't have any earthquakes maybe in the 10,000 years. This is actually a prototype for the water-powered 10,000-year clock. This is actually 12 stories high, and it's run by a river. They've actually purchased land in the U.S. out in the far west where they're thinking about putting this big giant clock. So imagine a big giant clock sitting right there, a 12-story clock. They're thinking very deeply about this problem of how do you represent things over really, really vast, long periods of time. But notice that this really is just an abstraction distraction. It really doesn't matter what format I keep it in. I need to keep that knowledge safe. But the format always gets mixed up in the knowledge, and I can't really divorce those two things from one another. And so my lesson number one is don't mistake the abstraction for the real thing. Don't think of it as the Word doc, think of it as the information. Don't get confused as to what you're actually saving there. Archiving is really, really important. Because if there is a piece of software that is definitely going to last for 10,000 years and may in fact become Skynet, it is Emacs. And tragically, the very first check-ins on the Emacs project, they still have the tapes, but they don't have a machine that can read the tapes. And so the very first check-ins of this probably most important piece of software ever created is now lost in time because no one's ever going to build a machine just to read that very specific magnetic format off those tapes. And so we'll never get those very first check-ins to Emacs back again. Now I'm going to tell a kind of a long story. And at the end of this story, two things are true. One of which is I probably should have ended up in jail, but I didn't. And the other is, this is going to sound like one of those really long, rambling stories from someone who gives you way too many details about things that you don't really care about. But trust me, all the details are kind of important to the story. And the story has to do with the way that I worked my way through university. When I was going to university, I worked my way through that job as the night auditor in a hotel. And it turns out this is a terrific job if you're in university because once you get the accounting done for the day, you actually have some time to do schoolwork, and so you can kind of multitask and get paid to study. And night auditor does kind of nightly, daily accounting and help with late check-ins and things like help with guest problems at night. But there are two other really critically important parts of the night auditor job description, and that is don't get drunk and don't go to sleep, both of which are very, very bad. And actually this works out really well if the manager knows that I'm in college and I'm doing college work at night because she knows that I'm not doing either of these two prescribed things, and she knows how I'm spending my time when otherwise you're kind of bored at 4 in the morning. I've got something to occupy myself, so that works out as a really good trade-off for job and work. When I first learned how to do night audit in hotel, it was purely manual, using very old school manual cash registers like this. And the way that audits work in hotels, basically everybody has a folio with a balance on it, and you add things up over a day, room charges and tax and restaurant, etc. And what you have to do is at the end of the day, add up everything that's been happening on these keys and take all the changes to everyone's balance that day, and those two numbers should equal one another. That's the idea of a night audit. And so what you have is a folio that looks like this, and on this old school cash register, you had to put it in and pick up the previous balance and then put a room charge in, and then it would generate the new balance, but it doesn't actually keep that sum. It's just putting it here. Only thing it's keeping track of is that I've rung up this much room and tax, and now this balance has been changed. And so that's basically the essence of the night audit. You take the sum of all the keys and then equals that the delta of the previous and new balances from the day before. And it's a little bit labor intensive because there's a lot of manual work, but there are really only a couple of things that can go wrong here. When you operate this machine, it's not smart enough to know what this previous balance was, so the person that puts the folio in the machine has to type in this previous balance correctly and then add a new charge to it. And one of the common mistakes that comes up here is when someone transposes the numbers when they put them in, they flip the numbers around accidentally. And of course, it doesn't show up in red on the piece of paper. And so you learn lots of little auditor tricks, like if the balance is off, if the amount that you're off is divisible by 9, it's probably a transposition error somewhere. Because transposition errors always yield a difference that's divisible by 9. That's just a little auditor's trick that you learn over time. The other problem that you would occasionally run into is that nothing forced you to make it really pretty and neat when you put the piece of paper in there. And occasionally people would get crazy and just stamp things all over it, and then you had to go find the actual audit tape and kind of deconstruct what they did. And then beatings ensued the next morning to try to make sure they never did that again. When I learned this was very intense and very manual. But then I moved to Atlanta and went to a different university, went to Georgia Tech and eventually went to Georgia State University, and went to work at a different hotel, the Regency Suites Hotel, which is actually still there in Atlanta. I was working as the night auditor there. And they had a significant improvement because they had a computer-based hotel system. And it was really slick. Now, this was in the year 1988 or so. So it ran on an IBM PC AT, which had a 286 processor in it, which is a very, very primitive processor. This had 640K of memory in it, and that processor. But these guys who had sold this software had figured out how to get this very underpowered machine to work as the host for a bunch of dumb terminals. So there was actually terminals all over the hotel, and it was all hosted off this one really, really primitive piece of computing equipment, and the networking and everything was built into it. I was impressed. I'm a computer science student. I show up, and this piece of, really constrained piece of hardware does this. It was actually written in BASIC with line numbers. So they'd done all this incredible work in a BASIC dialect with line numbers. So I was very impressed. But the audit in the new hotel was very different. Because in the new hotel, you're basically just running this series of programs and letting it calculate everything because it's keeping track of all the balances. And mostly what you did at the end of the night is fold a bunch of papers and file them away and then do a backup of the thing on 32 floppy disks, which was a real treat. But then every once in a while, it would get out of balance. And that just really confused me. I'm a computer scientist, and when computers do non-deterministic things, it annoys me. Because they're not supposed to do non-deterministic things. They're supposed to always work, and there were little bizarre bugs that would pop up every once in a while. And it seemed to happen, of course, when we were the busiest, when it was the worst time for it to happen. And then I realized why this was happening, because these guys had written a multi-user system based on this old computer with no record locking. As in no record locking, as in no locking whatsoever. My respect for these guys went from the highest mountain to the darkest pit instantly. It's like, what are you idiots doing? You're selling the software that people are running their businesses on, and you have multi-user access and no records get locked anywhere. It's just randomly last one in wins, and it corrupts records when you're busiest. And so I was appalled. And so I went to the hotel manager and explained to them how horrible this was, that we were using a piece of software that didn't do concurrency correctly. And she was like, so? So now I've got to figure out a way to explain to her why this is bad. So I came up with a plan. Here's what I did. So one night, late at night, I waited until somebody came in to check in late at night that purchased a room with cash. So I rented him a room, took his cash, sent him upstairs to his room. Then I went over and started the night audit on one of the terminals. Then when it reached a critical point, during the point where it was posting room and tax, I went and checked him in on another terminal and then immediately checked him back out. And that all happened while the audit was running, so it basically had no impact on the day's records. Took the money he had given me and put it in an envelope, wrote a date on it that was 1 week in the future, put it in the safe, and then went home. The next morning, the hotel's accountant came in, and then the property's accountant came in, and things were bizarrely off, and they couldn't figure out why. They were off by about a room charge worth. So they looked at this and pondered it. They actually imported a guy from the idiot software company, and he looked at it, and he looked at it, and he looked at it, and then he disappeared. I'm not sure what happened to that guy. Didn't see him anymore after a while. Meantime, I was just kind of hanging around. And when the date expired on the envelope, I said, oh, if you'll go to the safe and open that envelope, you'll find exactly the amount of money that you're off. And I'll explain exactly how someone can come in here with a little bit of knowledge and rob you blind overnight because they can take advantage of something called a race condition. Let me explain what a race condition is. That got their attention because now I had put it in the terms that they understood, which is, oh, because of this, someone can come and rip you off. But what they were suffering from was an abstraction distraction. Because all the people I had were working with had also come from the manual days of hotel. And so when they thought of folio, they thought of an immutable value. They didn't think of this digital thing that might change over time or might get corrupted when multiple people deal with it, because a piece of paper almost never gets corrupted when multiple people look at it and do things with it, because there's only one of them. There's a built-in locking mechanism with a single piece of paper that works really well. And they had a really hard time understanding that their metaphorical understanding of a folio did not translate exactly to what the computer system's understanding of a folio is. And this is exactly where this abstraction distraction can get you in trouble, because you believe it acts like something in the real world, and it actually doesn't. There's something sneaky going on behind the scenes. Which brings me back to lesson 1. Don't mistake the abstraction for the real thing. But that actually leads me to lesson 2, the way that I solve this problem, which is to always understand one level below your usual abstraction level. Don't get seduced by abstractions. Always understand one level down. That way, when it breaks in unusual ways, you understand that abstraction layer and can put it back together. Another kind of interesting observation about these, kind of cast in computer terms, while the manual system was very, very labor intensive, it also had some really desirable characteristics in that it was stateless. It kept no state except the numbers under the keys. It didn't keep any state on folios. That was on the piece of paper. Whereas the computer-based system was stateful. The manual system was simple. The computer-based system was complex in both essential and accidental ways. That it didn't work correctly was accidentally complex. The manual system was very nicely single-threaded, whereas the computerized system basically was a version of concurrency hell. So while it seems like the computer-based system is a lot better, from an architectural standpoint, it seems like the manual system looks a little better. The abstraction distractions happen in all aspects of your life. Here's an example. I realized at Christmas last year that the 3 generations in my family consume TV differently. Because we all have digital video recorders so that we can record and play back TV shows when we want. Now I've realized that I've been trained since birth that even though I'm watching a recording, I always wait until a commercial comes on before I get up and go to the restroom. I'll actually sit and bounce my leg waiting for a commercial, and then when the commercial comes on, I'll pause it, get up and go to the restroom and come back, because I've been trained my whole life you go to the restroom during commercials, not while the show is on. My mother, who's a generation older than me, doesn't believe that TV shows exist unless you watch them live. So I don't get to see my mother that much, so we're over to visit, and she'll say, oh, I need to go upstairs and watch Law and Order. And it's like, Mom, we're here. You can record that and watch it later. It's like, oh, no, I can't do that. Got to see it when it comes on or it doesn't really exist. She has a DVR, has to see it right when it comes on or it doesn't exist. My 9-year-old nephew doesn't care about when things appear. Everything is pausable in his life. Everything has a release date, and then it just can be paused and maybe never come back to. My friend Matthew McCullough has a 3-year-old daughter, and they watch cartoons a lot on the iPad. And one morning he got up and turned the TV on, and the show was already going, and she came in and said, Dad, why did you start it without me? And he had a hard time explaining to her, no, I didn't start this one. This one somebody else starts, and we can't control that. Which just really brings up my lesson 3. Once internalized, abstractions are really, really hard to shake off. And if you don't believe that's true, just look down. The QWERTY keyboard is not the most efficient way to type on a keyboard. The QWERTY keyboard was designed because of this. Typewriters originally had metal arms that would fling up and hit a tape against the piece of paper, and the problem with really fast typists was they'd get 2 of them going too close to one another and they'd jam, and then you'd have to pull it apart and white out and correct it. And so the QWERTY keyboard layout was designed to alternate hands as much as possible. So it's not the most efficient way to type. The Dvorak keyboard system is actually a much more efficient way to type, but try teaching yourself to type a different way. If you don't think abstractions get really, really firmly ingrained, try switching all the keys on your keyboard and see how long it takes you to be productive again or to pull all of your hair out. Which brings me to lesson 4. Abstractions are both walls and prisons. Very often abstractions at the early days are really beneficial because they're a wall against the chaos of the outside world. And we build up more and more walls around us until someday we realize we forgot to put a door in this abstraction, and now it's just 4 walls around us and has become a prison. Here's an example I saw in London of a sink designed by someone who has never actually washed their hands in a sink before. Because you have blazing hot water and ice cold water and no stopper, and there's no way to operate this with only two hands. You either get blazing hot water or ice cold water. You can never get both on both hands. It is designed by someone who's never actually washed their hands. That's an abstraction distraction. But, they had two pipes that came up to that sink. Once internalized, abstractions are really, really hard to shake off. They had two pipes, therefore they needed two spigots. I realized this many years ago because I, like many people, switched over from something like Outlook to something like Gmail. And when I first started using Gmail, I was kind of puzzled because I thought, well, wow, Gmail doesn't have any folders. These Google guys don't even know how to write an email client. They didn't even include folders. They did this tag thing. So I did what many of you probably did, was take your incredibly elaborate hierarchy of folders in Outlook and just recreated that as tags over in Gmail. Until one day you realized, wait a minute, tags are way better than hierarchy because I can tag multiple things. I don't have to firmly stick them into a hierarchy. Thinking that mail has to go into a hierarchy is just an artifact of the tool that you're using. And it turns out that tags are way better for this because you can tag multiple contexts on the same message. That got me to thinking, are there some other things in the world that are probably unnecessarily crammed into hierarchies? And I think maybe this is the way that we classify biology. Because if we weren't using a strict hierarchy here, but we're using tags instead, we'd finally be able to categorize this guy. This is a duck-billed platypus, who is a mammal that also lays eggs, and only their left ovary works for some bizarre reason. This does not fit into any sort of hierarchy in the animal kingdom because it's half of one thing and half of another thing. But if we were doing tags, we could model this with no problem at all. Even things as fundamental as physics. If you take cornstarch and water and put it and vibrate it at a certain frequency, it actually shifts between solid and liquid and comes into a third magical state that's neither solid nor liquid. So you can't even say that physical phenomenon fit into a strict hierarchy. You can tag this both solid and liquid at the same time. Abstractions are both walls and prisons. So I want to go into a little deeper computer science examples now. And I have a question for you. I'm sure a lot of you look at this all day. This is part of the toolbar for Word or one of the Office products. I have a really important question for you. What the hell is that thing? When was the last computer that you had that had a floppy disk drive in it? And yet you're still clicking on this floppy disk thing to save a file? So if that means save a file, what the hell does this mean? That my file's so big I need more than one floppy disk? How did this ever come to mean save all? That's the dumbest thing ever. And yet everybody still clicks on that dumb icon from a decade ago when you haven't even seen one of these in a decade, I'll be willing to bet. It's a classic example of an abstraction distraction. Leads me to number 5. Don't name things that expose underlying details. Don't put hardwired dependencies on things that are going to change over time. We'd be better off having some sort of abstract save icon because in 1,000 years, people are going to say, what's the little square thing with a something on it that said that means save? That's what that means. Don't ask any more questions. That just means save. One of the other abstractions that we are really wedded to as developers are things like hierarchical file systems. You know who doesn't want hierarchical file systems? Computer users. This is purely a convenience to make things easier on developers. I realized this when I was reading this really fascinating book by Jeff Raskin. who's a really well-known researcher in human-computer interaction. To give you an idea, he was one of the first guys to design some of the original Macintosh stuff. To give you an idea of the kind of guy Jeff Raskin was, when he was born, his name was spelled traditionally Jeff. When he became an adult, he legally changed his name to get rid of the extra inefficient F in his name. So that's the kind of guy Jeff Raskin was. And this book has a lot of kind of philosophical stuff about human-computer interaction. And one of the things he points out is that no user actually wants a file system. That's a developer convenience. How many of you have had a discussion with your grandmother that she's downloaded some family pictures and now they're somewhere in her hard drive and now you're on the phone trying to navigate her file system, try to find those things? Having a nice kind of consistent user interface like Windows is a really nice abstraction, but it sometimes kills off other things. Does anybody here recognize this piece of software? This would be bizarre if you did. This is a piece of DOS-based software called Magellan that Lotus came out with many, many years ago. This is a really super powerful piece of software. It would actually, back in the days of DOS, let you do index searches across the contents of your hard drive. They had some really wicked, really tight indexing algorithms, so you could do incremental searches across your entire hard drive. Really fantastic file utility, but it didn't fit into the normal kind of Windows, icons, mouse, etc. It was all function key driven, and it did not make the transition over into the Windows world of icons, etc., because they didn't want to completely change this user interface. So what happened was, when Windows came along, while it gave a really good consistency to everyone, it also took away a lot of innovation in the UI space, because abstractions are both walls and prisons. When Windows came out, when the Macintosh came out, it was great. Now we have consistency across applications, but before long, that very consistency becomes a prison, and you can't build innovative UIs because you can't break those rules. And we found that in a big way a few years ago when the first computer in about 25 or 30 years that did not adhere to the Windows, icons, mouse, pointer metaphor came out, the iPad. Because the iPad doesn't have the abstractions we're used to. It doesn't have a keyboard, it doesn't have a mouse, it doesn't have a file system. But of course it has a file system. It's Unix underneath. They just never show the file system to the end user, because the end user doesn't want a file system. They just want applications that work. They don't want things that confuse them, and where to put things confuses them. So the only kind of file system you ever see manifest on the iPad are things that come from the cloud or something that you pull in. There's a very well-known place for this application to go get its stuff. Which brings me back to lesson 3. Once internalized, these abstractions are hard to shake off. I want to go a little deeper for a second and talk about some language abstractions. This is a Java conference, so presumably everyone here is pretty familiar with Java. And I want to talk about some of the core building blocks of Java for a second. So let's say we have this relationship between a point 2D and a point 3D. And I have a draw method. And of course we know how this is actually implemented underneath. There's a virtual method table that has the implementation for these guys. And the way that this works in inheritance is that if I don't have a particular implementation, then it just points back up to the implementation for my parent class. That's how you resolve which method to call when this needs to be called. Does it look up in the virtual method table and decides to resolve which one it wants. But ultimately, this is a coupling technique. It's a very well-defined way to couple two classes together with a bunch of rules about how that coupling works. I'm sure many of you are familiar with this book, Effective Java. If you're not, you should be. It's a terrific book because it has a lot of really good best practice kind of stuff in it. One of the best practice things in Effective Java is how to write a proper equals and hash code method. And so let's poke into that just a little bit. So we have our point 2D that looks like this. It's easy enough to follow his magic formula for an equals method. We need to do an instance check and then a typecast and an equality check. Okay, that all looks pretty good. That meets all the rules. But now I'm going to run into trouble as I try to write the equals method for point 3D, because if I try to write it like this, I end up violating symmetry, because the rule says if x equals y must return true if and only if y equals x returns true, and 0.2Ds don't know about 0.3Ds, so they can't be symmetrical like this. Okay, well, we can fix that by adding some more code to it, but then when we try to do this, it violates transitivity. That says if x equals y returns true and y equals z returns true, then x equals z must also return true. The problem is you can't really add awareness to subclasses and supertypes, etc. In fact, in effective Java, Josh Block says there's no way to extend an instantiable class and add a value component while preserving the equals contract unless you're willing to forego the benefits of the object-oriented abstraction. So from what he's talking about, it almost makes it sound like he's saying that object-oriented programming is broken. But we know it's not broken. It works perfectly fine. There are just some edge cases that you have to know how they work, and that's part of what you learn as you work on object-oriented languages. And of course, there is actually a solution for this problem as well. The Scala guys have figured out a way to solve this problem by adding a third method to equals hash code and has a can equal method that lets you send should I try to achieve equality up and down the hierarchy. But object orientation in some ways is an abstraction distraction. If the only thing you ever use is an object-oriented language, you start believing things like inheritance polymorphism can only work that way. And when they break in common edge cases, you're kind of puzzled because it's like, well, wow, my abstraction should work and handle all these common things, and yet very often it doesn't for one reason or another. Which brings me to lesson number 6. No matter how good it is, your abstraction isn't perfect. It is an abstraction on top of something. It's not the real thing. If it were the real thing, it wouldn't be an abstraction. So by definition, some parts of the real thing are being left out and being generalized on. Think of this kind of behavior, the way that polymorphic dispatch works, is just a core way that languages work. And in fact, this is the way that Java works. In fact, inheritance and polymorphism are very intimately coupled in Java. You don't get polymorphism without inheritance in Java. Those two things are very tightly coupled together. So you basically have polymorphic dispatch keyed on type. But then you might look at a language like Clojure. Clojure is a functional programming language that is not particularly object-oriented. And so you may look at that and go, well, it clearly can't be as powerful as Java because Java is object-oriented. But Clojure is as powerful. The difference is all those features are available a la carte. Polymorphism still works. It's just not tied to inheritance. It's completely free, and you can do anything that you want. Clojure has this idea of a multi-method where you can say, I want to define a method that will actually dispatch on any criteria that I want. Not only just a single type, but any field in the class or any combination of fields in the class, and get polymorphism that way. It has configurable polymorphic dispatch at the language level. And in fact, it can fix some problems that are inherent in the way that Java handles things. One of the problems you run into in Java is if you have something that matches two interfaces and you can't figure out which one you need to refer to, there is actually a prefer method in here that says, well, if they both match the same interface, then prefer this version to call it versus this other version. Here's another example. I'm sure many of you in here recognize this book. This is a classic Windows programming book by Charles Petzold, the original programming Windows book. And many of you who did programming in Windows know what one of those is. What is that? A long pointer to a string. These show up all over the place in the Windows API for handles on things and strings, etc. And in fact, if you look at something like this is the Win32 Programmer's Guide. This is the Forger's Win32 API programming tutorial. And you zoom in a little bit, talking about Win32 data types. And he says at one point, an LP prefix stands for a long pointer. In Win32, the long pointer is obsolete, so don't worry about it. It's obsolete, but it's there on every single function call. When we went from 16 to 32 bits, long pointers didn't mean anything anymore. That was purely a 16-bit convention, and yet the Windows API had these prefixes all over the place. So in 10,000 years, when somebody's programming Windows, they're going to say, what's an LPSTR? And it's like, oh, don't worry about that. That just means it's a string. But that's a classic example of an abstraction distraction. Hungarian notation is a classic example of abstraction distraction. Your abstraction shouldn't care how they're represented underneath, and that becomes a smell when those two things are tied too closely together. Which brings me back to lesson 5, don't name things that expose underlying details. And also, lesson 7, understand the implications of rigidity. Don't build rigidity into your systems because that will keep manifesting over long periods of time. Next, I want to talk a little bit about leakiness. And this idea of leaky abstractions. Joel Spolsky, many years ago, wrote a great blog entry where he talked about the law of leaky abstractions. And basically the law of leaky abstractions says that all non-trivial abstractions to some degree are leaky. Meaning that they don't perfectly abstract away the thing that you're trying to hide the details of, that some of those details kind of leak through. And the way that he was talking about this was universally kind of a bad thing, that leaky abstractions were improperly done abstractions or not as robust as they could have been. But you can take another perspective on this as well. My good friend Glenn Vanderberg has an interesting take on this where he says that some leak in better ways than others. And the best abstractions leak intentionally in carefully chosen ways. And he has defined this idea that I'm going to relate to you now of an onion skin API, which is a high-level abstraction built on top of an equally well-documented lower-level abstraction. I'll give you a good example of one of these. Rails Active Record is a classic example of an onion skin API that's meant to leak in very specific ways. Rails Active Record basically has 5 layers. You have a vendor-agnostic database connections of facilities at the bottommost layer. You have a query to object instances layer that gives you object instances back from queries. They've recently added the ability for SQL fragments to be composed into select statements. Then you have a layer of query as high-level relational algebra methods. And then at the top, you have query instances of particular classes with associations. Any sort of non-trivial Rails application or most tutorials just talk about this top layer. Just about any non-trivial Rails application will get down to at least the 3rd layer in this abstraction. And that's one of the tricks of learning Rails is how do you take advantage of the pieces that they have purposely let leak because they decided we can't solve every problem, so we'll just get out of the way of the ones that we can't solve. In fact, it's not that uncommon to actually go all the way to this bottom layer for reporting and some other low-level stuff like that in a fairly robust Rails application. So this is my lesson number 8, which is a good thing, not a bad thing, that good APIs are not merely high-level or low-level, they're both at the same time. And this reflects a statistical phenomenon that happens all the time in the software world. This 80-20 rule, or the Pareto distribution in the statistical world, this 80-20 rule, and it turns out that OR mapping is very much like that. 80% is pretty easy and nicely, cleanly abstract. Last 20% is really hard. And so the Rails guys have said, you know what, we're not even going to try that last 20% because that's where all the really hairy complexity lies. We'll just make our 80% abstraction leak in well understood ways and let you do what you need to do to solve your problem. Which brings me to lesson 9 that says generalize the 80% cases and get out of the way for the rest of them. Choosing the wrong abstractions can sometimes be physically dangerous to your body. And all you have to do is go find a Galileo to find that out. Galileo believed in a particular abstraction that someone had come up with just before him. At that time in the world, the common thinking in the Catholic Church was that the Earth was the center of the universe and all the other planets revolved around it. But Galileo had caught onto this Copernican idea of the universe, and he had observed this through his telescope, and he believed that the universe actually looked like this. But he couldn't convince people, and in fact, the church pestered him and kept him from talking about his scientific discoveries, basically cast him out of his community and threw him out of the church, basically drove him nearly insane, and he died basically a miserable death because he believed too deeply in this one abstraction. Which brings me inevitably to Maven. One of my colleagues is the most good-natured guy you'll ever meet, Kent Spillner, and he has this to say about Maven. Maven builds are an infinite cycle of despair that will slowly drag you into the deepest, darkest pits of hell where Maven itself was forged. Now, what would make a mild-mannered developer say such horrible things about a tool like Maven? And it got me curious because I've noticed that virtually every project that starts Maven loves it at the beginning, and at some point they rip it out with great, great fury and anger toward the end. And I got curious as to why that is. And I did some analysis on this. In fact, I split developer tools into two categories: composable versus contextual tools. Composable tools are things like bash. That's the classic kind of composable tool. Every bash command produces text and it consumes text. And so you can wire together all these really elaborate magical things that can happen to the command line that I'm sure even the bash designers would have never anticipated that you could do all that stuff. Versus something like PowerShell, which is more property-based, which means it's easier to do things in PowerShell because you don't have to parse dates and stuff like that, because dates have properties, but it doesn't have quite the flexibility that Bash has because you can't get as low as you can in Bash. Build tools are this way too. Rake and Gantt and Gradle are all language-based build tools. Ant and Maven are all plugin-based build tools. This applies to tooling as well. Emacs and VI versus something like Eclipse and Visual Studio. I ask a lot of Eclipse developers, when was the last time you modified Eclipse outside the preferences dialog? In other words, when was the last time you cracked open the Eclipse API to go modify the way that it does something in that environment? Most Eclipse users never do that because it would take you a week to learn enough just to build a Hello World window in Eclipse because it has this gigantic context you have to learn. If you talk to Emacs and VI users, never a week goes by that they don't tweak something about how their environment works because it's built of these little tiny pieces that you can kind of see and understand in a much more limited way. In fact, this applies to languages and frameworks too. Languages are very, very composable, and frameworks very much less so, because frameworks have an opinion of the way they put their API together, and as long as you agree with their opinion, everything is great. But when you have to start diverging from that opinion, that's when things go bad. Now, I'm casting this as if context were a bad thing, and it's not, because when you have more context, you get more behavior directly out of the box. You get more contextual intelligence, but you get less long-term flexibility. Versus composable systems, you have less implicit behavior, but you have better building blocks, and so therefore more eventual power with less initial power, but greater flexibility. And I was talking about the Pareto distribution before. Here's another way that it manifests. It's something that I call Detours Law. I coined this phrase in my book, The Productive Programmer, and this is based on a colleague that I used to work for named Terry Dietzler. I used to work for a consulting company, and we had a division that did development for clients in Microsoft Access. And we ended up shutting down that division because we realized that every single Access project starts really great and the client's really happy, and they all end in failure with the client really mad. And we wanted to figure out why that was. And we eventually figured it out and coined it as Detours Law. When you think about what your user wants, if you're using a tool that has a lot of built-in context, like Access or something like that, then 80% of what the user wants is really super fast and easy, and they're stunned at how fast you can get it put together. But then the next 10% of what they want is possible, but difficult. Because now you're doing something that the framework doesn't particularly want you to do. And now it's going to start fighting you a little bit. So you have to hack it and figure out a way to, get something underneath it and figure out a way to bolt something on the side of it, kind of massage it to get it to work. But the problem is that last 10% is impossible. because you can never get far enough below the framework to get everything done that you need to get done. And Detours Law is basically that users always want 100% of what they want. They're never satisfied with 90% of what they want, so every project that uses this ends up in failure. Back in the late 1990s, there was a huge number of these fourth generation languages that were popular. XBase and FoxPro and Paradox and PowerBuilder. All of them are gone now. Why are they gone? They're all gone because they suffered from Detours Law. 4GLs tried to do a lot of really good stuff for you, but you always reached a point where it's like, I can't get far enough under this abstraction to do what I have to do. That's why we're all back to general purpose programming languages and tend to stay there. But this becomes a really tricky thing, because how do you choose? Because Maven is awesome when you're starting a brand new project. So you want to start with the easiest thing. But when you have a brand new project, you want a tool that's opinionated, because you don't have any opinion, it's brand new. You want one that's dogmatic, that says, you will put your directory structure like this. Okay, good. That looks like a pretty good directory structure to me. We're good with that. And rigid and generic are all really good things when you start a brand new project. But projects over time become more unique. And these really nice things that you got started with a nice, be able to plug in and all that sort of stuff, these nice things start turning ugly. When you realize that, I'd really like to be able to run my unit test without having to compile my code a second time, but you can't get far enough under Maven's abstraction for how it does builds to tell it, no, stop that, I want you to do this extra step before you do this compilation step. And so you end up hacking it to do some other kind of thing like that. All these things that are nice in the early days become disadvantages later. And for any tool like this, you'll reach a tipping point. This is the day when it stops being beneficial and it starts fighting you. And from this day, it will never, ever be wonderful again. It's only going to be bad from here on out. So the real trick is not to avoid tools like Maven, is to understand when their expiration date is. Everybody hates to throw away what they view as good, sunk work, and you hate to cut away from something like Maven because there's a lot of ability in there. But if it's going to start fighting you and making your job harder rather than easier, then it's time to say goodbye to it and find something else that solves your new, more nuanced, more complex problem. And the nice thing about this world, at least, is that there's kind of a get-out-of-jail-free card in the Java world for Maven called Gradle, which uses some of the Maven concepts, but it's language-based rather than plugin-based. That's a lot of where the rigidity in Maven and Ant comes from. These plugins are very coarse-grained abstractions, and if your abstraction, what you need to do, doesn't fit into those abstractions, you can't get underneath them. So at some point you have to cut and run, but that becomes the really important decision, is to use tools like that to provide value, but make sure that you understand the day that they stop providing value and find something that gives you a new level of value. I picked Maven because uniquely it exemplifies almost all of my bad abstraction distraction, and it does not exemplify either of my good ones. So it is a great poster child to say bad things about. I actually wrote up my opinions on Maven by request at some point, so if you want this written down so that you can take this to someone and beat them to death about Maven with it, then it's there on my blog if you're interested in it. So I've been talking about the hazards of abstractions all morning. Is there one true abstraction that has no disadvantages? Probably not. But if I had to pick one, I would say that the closest contender would probably be something like composability. Because if you look at some of the problems I brought up before, composability is the answer. This is exactly how Josh Block suggested you solve this problem in Effective Java. This would be kind of a terrible Effective Java book if he said, oh, by the way, object orientation is broken, good night. He gave you a solution to the problem, which is use composition instead of inheritance, and that solves that problem. This also solves some problems with things like version control. Git is also an onion skin API, and that's one of the really, really powerful things about Git, is that it has a top-level API that you interact with that's written in Perl. The really low-level pieces of Git are little bitty tiny C programs that the higher-level abstractions wire together to do useful stuff. But once you understand how those really low-level abstractions work, you can build your own workflows out of those little atomic building blocks if you want. Really advanced Git shops don't use the top-level abstraction anymore. They use a lower-level one because it gives them more power and it allows them to wire up their workflow and their version control exactly the way they want to. I also mentioned fourth-generation languages. It seemed like a pretty good idea, but they died away. But they have come back. Because we're solving that same problem now with domain-specific languages. DSLs are 21st century 4GLs. Because the 4GLs, the promise of the 4GL was I'll give you a nice high-level abstraction so that you don't have to wallow around in all this really specific stuff all the time. But then the problem came, it wouldn't let you get under the abstraction. A domain-specific language, particularly an internal domain-specific language like Ruby on Rails, gives you the same high-level nice abstraction, but because it's written on top of a general-purpose language, you can dip one abstraction down and get to those underlying abstractions if you need to. This is the way that they're solving Detours Law in frameworks like Ruby on Rails and Grails, is they're using composability and building domain-specific languages on top of those guys. So I'm wrapping up. Some of you may wonder what I ended up doing about Mary Long's chocolate cake. How did I end up saving this permanently? Well, I've used computers for a really long time, and I am really paranoid about them. I've seen lots of computers die. In fact, it's more common for them to die for them not to. So I decided I'll keep Mary Long's chocolate cake in Unicode and in Markdown, which you can kind of produce into HTML, but it's a really clean text format. And I back it up using a RAID drive, Crash Plan, which is an off-site electronic backup, and a physical off-site backup disk. This is a backup scheme that I refer to as suspenders, belt, and duct tape. I never trust computers with anything. If you've lived with computers for a while, you have been nabbed by the abstraction distraction of the blue screen of death. That is the classic abstraction distraction. You're typing along, and all of a sudden, all of your metaphors disappear. And your first thought is, how much have I lost since I saved the last time? Which is actually an interesting another abstraction. The save button is going away slowly. In fact, the new Mac guidelines say never put a save button on there. That's another pure developer convenience. Why doesn't it just constantly save itself in the background all the time? We have plenty of processing power to do that. Why are you forcing the user to remember go up and click your dumb button every 5 minutes or so just to save what they're working on? Shouldn't your computer be smart enough to save the stuff that you give it? I think it should. And so my lesson number 10 is no matter how much they try, don't be distracted by your abstractions. I have one last piece of advice for you. Please enjoy the rest of the conference.
Since we have a couple of minutes. You can raise your hand if you have a question.
The onion skin API stuff is composable. The really interesting thing about composability, though, is when you get into places like functional programming, because that's the real key in functional programming is rather than work directly on collections, compose the functions together and then apply that composed function. And very often you can do less work. So for example, let's say that you have a list of last names and you want to filter them for all the names starting with a certain letter, and then you want to uppercase all of them. Well, using traditional iterative techniques, you'd go through and operate on all of them to do those things. Using functions, what you could say is, well, let's put the functions together so that I end up capitalizing the fewest number of them because I've already done the filtering operation. You can actually be intelligent about the way you chain the functions together to do a lot less work. So that's actually one of the secrets to the nice benefits of functional programming is that it relies heavily on composition as one of its primary abstractions. So that's an example. The 4GLs is an example. The onion skin API is an example. And in some ways, DSLs are an example of composability, but a little less so.
Okay, thanks.
Question like, how much mutability should we have in my application? The answer is as little as you can get away with. And that's what I'd say here. I mean, you can't build perfectly composable systems, but you can get pretty close. And you can make a much better effort than most people do now. So I agree that you don't live in a perfect world, but you can definitely start taking more advantage of this. I actually see inheritance way overused out in the world, and composition way underused, even in object-oriented systems, not even the functional world. And I think people would benefit more because it ends up having less kind of weird downstream odd things happening because of conflicts around equality and other things that exist in the hierarchy.